Let's try this again. Let's see, I think I finished number 2 and I was going on to number 3. We had done arc length, and now we're moving on to velocity. Sorry, my computer died there on me. So we're again looking at this projectile with x at t being 5t cubed plus 8t squared, and y at t being 50 minus 2t squared. Alright, now here's one more time, like question number 1, where what you usually do to find velocity doesn't quite work. So we do still find the derivative. So velocity from position, you do still find the derivative. X prime at t is 15t squared plus 16t. And y prime at t is equal to negative 4t. Now, if you were usually finding dy dx, you would then divide those two, as the formula says, for parametric equations. So you would have negative 4t over 15t squared plus 16t. And if you wanted to find the velocity, you might think you'd plug in t equals 6. But that won't actually find you the velocity. When you have this parametric equation, I didn't actually graph it, as I probably should have, but it's a projectile. It probably goes something like that, hopefully, if I did the problem correctly. And if you plugged in 6, that would instead give you a point over here. It would tell you the change in y over the change in x. It would give you the slope, which makes sense, hopefully, but not the velocity. And let me show you why, and hopefully this will stick with you. If I plug in t equals 6 into these equations, so x prime at 6 would equal 636, and y prime at 6 would equal negative 24. And so if you plug those in, you get these numbers. Those are the two velocities. That 636 is how fast you are going to the right. And negative 24 is how fast, in this case, because it's negative, you are going down. So if you're going 636 to the right, and you're going negative 24 down, you're actually going at a diagonal. You are going at this diagonal, right there. And so if you want to know how big that diagonal is, how fast you're actually going in that direction, as you can see the right triangle here, you have to do the Pythagorean Theorem. 636 squared plus negative, or just 24 squared, the negative doesn't matter, and the Pythagorean Theorem, you'll take the square root of that, and you'll get pretty much the same thing, 636.453. That would be your speed. We're not going to talk about velocity with this. That would be how fast this particle or this projectile is actually going. Whereas if you did dy dx and you plugged in 6 into this one, that would give you the trajectory or the slope. We'll talk more about this when we do vectors in a few weeks, but that is still something you can do with parametrics. This here is a lot of vector notation, but it makes sense because it's just the Pythagorean Theorem. Thankfully, that makes number 4 very, very easy, because number 4, I'm asking you, is the projectile going up or is it going down? And so you just have to look at the y value, what is the slope, or sorry, what is the value of y prime at 6? Because that will tell you what's happening with the vertical component. Because that equals 24, we already found that. The particle is obviously going down. So thankfully, that was quite easy once you do number 3. That makes some sense. Again, we will continue looking at these similar problems when we do vectors. Alright, the last one from my problems, number 5, is simply asking for the arc length of an equation. What was it? It was e to the x over x squared. Alright. This one shouldn't be too hard as long as you remember the formula. It is the integral from, I believe the interval we wanted was from 1 to 6, if I wrote it down correctly. It's a square root of 1 plus the derivative squared. So we need to take the derivative y prime. You'll want to rewrite y as e to the x times x to the negative 2, I imagine, to avoid the quotient rule. And so y prime is going to equal e to the x, x to the negative 2, the derivative of e to the x is e to the x, plus, let's see, negative 2x to the negative 3 e to the x. So then pull out an e to the x. Actually, you could pull out an e to the x and an x over 2, right? Or an x squared. Times be 1 plus, oops, sorry about that, 1 minus 1 minus 1 over x is all that's left over. Nope. 1 minus 2. Don't want to forget the coefficient. And so all that has to go in here. Now you want to make sure that when you plug this into the calculator, you make sure you do actually square the first one. So you will want to put parentheses around that when you do the squared. And so you will end up with a double set right here. The first time I did that, I made a mistake and got an error on my calculator. But if you get that typed in correctly, you should get 12.162 as the arc length. Again, that's following the formula. So hopefully that one makes sense and you can check your answers there. I'm going to go ahead and start a new video for the free response problems.